So a hypothesis test can tell us that we have strong evidence that a graph makes a difference, but it doesn't tell us the size of that difference. To estimate the size, we're going to need a confidence interval, and specifically, since this is quantitative data, we're going to do what's called a t-interval. So we want to use the sample difference in means, which is 0.704, to estimate the size of the true difference in means. So I'm using mu for that. Y'all are going to kill me. So I messed up the symbols. In this class, I think we say X bar for the sample means. Also, it looks like I've used a third label, graphs minus no graphs. Hopefully you know how I'm labeling the groups. Sorry, I'll try to do better with that. Okay, so the formula to calculate a confidence interval is a statistic plus or minus a critical value times the standard error. Sometimes you hear about the margin of error. That's just a name for all of this. The critical value times the standard error, all of that together is called the margin of error. So let's go over these pieces. The statistic here is just the difference in the sample means. So you can sort of think about this as like your best guess for the parameter. The value that you calculate from the sample would be your best guess. The standard error, we already saw the formula for that. So that was the standard deviation of group 1 squared over the sample size for group 1 plus the standard deviation of group 2 squared over the sample size for group 2. So basically, when you calculate your standard error, that's a way of answering how precise is your estimate, right? How much variability are we expecting sample to sample in the data collection process? And this depends on your sample size, right? As your sample size gets bigger, your precision gets better, right? Or the standard error gets smaller. The last part is the critical value, and sometimes you'll see the symbol T star when you're talking about quantitative data. So this is sort of answering the question, how confident do you need to be? So this is going to determine how many standard errors you're going to add on each side. So just kind of as a rough rule of thumb, if you want to be 95% confident, your T star is going to come out to be roughly 2, close to that. But instead of like figuring out what T star is and then putting together the formula by hand, I think it's a lot easier just to let JMP calculate this for you. And luckily the confidence interval comes out in the same output as the t-test. So where it says upper CL diff and lower CL diff and then confidence 0.95, that's what we're using here. So the default is a 95% confidence interval. So our 95% confidence interval would go from 0.033, and it is like customary to write the smaller number on the bottom or the smaller number first, up to 1.375. So that's our 95% confidence interval. And to interpret a confidence interval, we say we're 95% confident that our true parameter, and in this case, that would be the true difference in the means, and we'll say this in context, so the true difference in mean ratings. And we saw in a previous video how the order of subtraction can change the sign. So we do want to specify graph minus no graph, or however you're labeling these groups. The true difference in mean ratings, graph minus no graph, is in this range. So it's between 0.033 and 1.375. You could also say that including the graph increases the average rating by this amount, by 0.033 to 1.375. Either one of those are okay. So the key things here, one, it needs to be really clear what your parameter is. So you can either say it explicitly like we did here, the true difference in means, or you can say on average and compare the groups to make it clear that you're comparing two means. The other thing is that the direction needs to be really clear. So the way I've written it here, I did graph minus no graph to make it clear, but you could also say, adding a graph increases the ratings. That would be another way to get direction in there. So parameter needs to be really explicit. Direction needs to be explicit. And there's actually connections between confidence intervals and the hypothesis test that we did earlier. So if your confidence interval does not include 0, basically what you're saying is that 0 is not a reasonable value for the parameter, right? So this is consistent with the fact that we rejected 0 earlier, right? Our null hypothesis was that the parameter text and graph minus text only, that the parameter was equal to 0, and we rejected that in favor of the alternative hypothesis. So this means that our p-value must be less than whatever cutoff we're using. We call that alpha. So our p-value is less than alpha. I should specify that when we say p-value, really we mean the two-sided p-value. So like here, 0.04 is less than alpha. Confidence intervals have an upper and a lower bound, and so they're going to correspond to a two-sided p-value. By the way, this connection goes the other way. So if you know that you have a small p-value, that would mean that you would reject the null hypothesis. That means that the null hypothesis value is not going to be inside the interval. So this works for confidence intervals and two-sided p-values. The other sort of technicality I should mention is how confidence levels correspond to significance levels. So a 95% confidence interval corresponds to an alpha of 0.05. So those are both kind of the most common levels. Notice that they add up to 1. 0.95 plus 0.05 add up to 1. They're sort of complements of each other. So 99% confidence would correspond to an alpha of 0.01 to make it add up. And 90% confidence, those are sort of the three most common ones, would correspond to an alpha of 0.1. And like I said, the default in JUMP is to do a 95% confidence, but you can change that. So I'm going to go back to that red arrow and go down where it says set alpha level, and then you just pick the corresponding one. So like, let's say I want 90% confidence, I would pick 0.10. And you can see here my confidence level has changed to 0.9, so that's 90% confidence, and my confidence interval has changed.